All right, we're now looking at 8C.4. And now all we're looking at is real world problems. So 8C4 is I can solve real world problems by finding the length of an arc or the area of a sector. Okay? So one of the biggest things we have to do when we read each problem is decide which of the two we're going to be doing. Is it talking about a length, like a distance, or is it talking about an area? Okay. So looking at number 1, or example 1, if this there we go. Example 1 says, a round pizza with a 16-inch diameter is cut into 6 congruent slices. What is the area of one slice? So we kind of already looked at this problem, right? But it's okay to look at it again. So this is going to be an area problem because it's asking what is the area. So again, remember, we have our pizza, 6 congruent slices. That's not going to give me 6. There we go. Those are our 6 congruent slices. What is the area of one slice? So I'm just looking for one, and remember, I have this 16-inch diameter, so the radius equals 16 over 2, which is 8. And then looking for the area inside. Okay. So again, the area of one slice is going to equal the total area, pi r squared, r was 8, of all 6 slices, right? The area of one slice is equal to the total area of all 6 slices. So again, now I'm just cross multiplying. I have 6 times x equals 1 times pi times 8 squared. This thing is going to drive me crazy. One times pi 8 squared is going to be 64 pi. Okay. To solve for x, we're just dividing by 6. 64 divided by 6 is 32 thirds, so 32 pi over 3, and this is in inches squared. Right. Okay. Looking at example 2, the windshield wiper of a car is 24 inches long. In one sweep, it turns through an angle of 115 degrees. How far does the tip of the wiper blade travel? So again, for this one, are we finding a length or an area? Well, how far? That's your key word there. That's going to talk about arc length. So kind of looking at your question and seeing what your key word is. So then I'm going to draw a picture. So a wiper blade doesn't travel in a circle, but right, in a whole circle, it only travels 115 degrees of the circle, right? So the wiper blade would be just going back and forth up here, but we can imagine the rest of the circle if it went all the way around, okay? And since the wiper blade is 24 inches long, right, that is just the radius, right? That it's at the center and goes out there. Okay. So now all I'm doing is finding my arc length. So again, the length of my arc over, right, it's traveling 115 degrees, is going to be same as the length around the whole circle, 2 pi r for circumference, if it traveled the whole circle, 360 degrees. Okay. So again, now I'm just cross multiplying, right? So I have 360 times x equals 115 times 2 pi times 24. So 360x equals 115 times 2 times 24 is 5,520 pi. This is a 24 there. Then I'm going to divide both sides by 360. Um, 5,520 divided by 360. We get 46 pi over 3. And this is also in inches. And it's a length, so it's just inches, not squared. Okay. All right, looking at example 3. A tire has 14-inch radius. What angle has the wheel rotated if the car moves 2 feet? So are we going to be setting up an arc length or a sector area problem? Okay. Well, I'm finding the angle, so that doesn't really tell us anything there, but the car moves 2 feet. That's a distance, right? That's talking about a length, not an area. So this is going to be an arc length problem. So if I draw my wheel, my tire, all right, we know it has a 14-inch radius. And I know the car is going to move, so that wheel is going to go around the outside 2 feet or 24 inches. Okay? And then I'm trying to find my angle. Remember, the variable we use for angles is that theta. Okay? So I'm going to set up my problem the same way. I just have a different variable now. I know how far my car goes. I know my arc length. So my arc length over my angle of that arc, which I don't know, that's just theta, has to equal the length around my whole circle, which is still going to be my circumference, 2 pi times 14 over the whole thing. And I'm just going to use, we're going to find it as a radian. It's a little easier in radians. So over 2 pi. Okay. So then, the next thing we are going to do is cross multiply. So I have 2 pi times 24 equals 2 pi times 14 times theta. All right, remember, theta is my variable. So I have 48 pi equals 2 times 14 is 28 pi times theta. And I am just going to divide by 28 pi. So 48 divided by 28 is 12/7, and the pi's cancel out. Okay. So my angle is 12/7 radians. Okay. And we could put that in degrees. You could find it in degrees if you just used 360 here instead of 2 pi. I'm not going to be picky on that. I just think it's easier because these pi's cancel out, so you don't have to worry about pi as much, and you find it in radians. All right, looking at our last example, number 4. In the diagram below, A, C, and B, D are arcs of circles with center at O. So technically I have 2 different circles. I have a smaller circle and a bigger circle. They just didn't draw the whole circle. The radius O to A is 10 centimeters. And then the radius O to B is 16 centimeters. I want to find this shaded area. Oh, that didn't change colors. A lot of times when you have a shaded area between two pieces, all I'm doing is I'm going to find this larger sector, right, which is this whole thing. I'm going to call it the big sector. And I'm going to take away the little sector here, right? If I have the blue and I take away the red, all I'm left with is that green. So minus the little sector. Okay. So then, we need to find the area of the big sector. Okay, so my area of the big sector, x, over this angle, which it told us was 95 degrees, is going to equal, right, the area of the whole circle, which is pi times the blue radius is 16 over 360 degrees. Okay. Cross multiply 360 times x equals 95 times pi times 16 squared. 360 times x equals 95 times 16 squared, which is 24,320. I'm going to divide both sides by 360. By 360, I get 608/9. So 608 pi over 9. Okay. Now, I have to do the same thing for my little sector. Okay, so I'm just setting up another area problem. Again, x over, well, if I look at my little sector, the angle is still 95 degrees, equals the area, if I had a whole circle here, would be pi times 10 squared over 360, right? So the only thing that's changed is I have a different radius. Cross multiply 360 times x equals 95 times pi times 10 squared. 360x equals 95 times 10 squared, 9,500. I'm going to divide both sides by 360. $9,500 divided by 360 is 475 over 18. So the last thing I'm doing is I'm doing the big minus the little. So I am just subtracting these. And my total equals, right? So I'm going to write, I don't even have to worry about the pi. The pi is still going to be there since they both have a pi. 608/9 minus 475/18. I'm just subtracting these two fractions. Pi is still going to be in my answer. It's like x, right? 5x minus 2x is 3x. Okay, so I'm still going to have that pi. So it's 247 pi over 6 centimeters squared. All right, that is it. Go ahead, look at your activity.